Alright, let's dive right into the different ways we can host our Blazor apps. If you're new to Blazor, don't worry, I'm going to make this as clear and simple as I can. We have three main ways to host a Blazor app: on the server, and when we say server-side hosting, we mean that the app runs on the server just like a traditional web app. In this model, each time the user interacts with the app, data is sent to the server and back to the client. This is quite similar to how many web apps have been built for years. The second approach is the client-side approach, also known as the client hosting model, or WebAssembly, or WASM. In client-side hosting, the app runs directly in the user's browser. This is pretty similar to how modern JavaScript frameworks like Angular, React, and Vue work. The entire app is downloaded to the browser and runs there. The third model is hybrid hosting. In a Blazor hybrid app, the app runs directly on the user's device, not in the browser. These apps can be built using different .NET native app frameworks, including .NET MAUI, WPF, and Windows Forms. This way, the app has full access to the native capabilities of the device through normal .NET APIs. Alright, let's dig a little bit deeper into each model's pros and cons. First, server-side hosting. The initial load time is faster since the entire application front-end code doesn't need to be downloaded to the browser. There's also better code security as the app code remains on the server. For this model, there's full debugging support through Visual Studio, and you can use any .NET Core library, even those that are not compatible with WebAssembly because, well, they run on the server. As for the cons of the server model, it does require running a full ASP.NET Core server, which needs to always be available, and that presents its own challenges. Offline scenarios are more challenging to support here as well. If the server is down, then your application is down. User interactions need to go to the server for processing. This requires low latency for a smooth experience. And finally, scaling can be a little bit more difficult if your server has to handle many client connections at the same time. Alright, on to client-side hosting. Here, the Blazor app runs entirely in the browser, so there's no need for server round trips for each function call, which makes the app really responsive. And because of this, support for offline scenarios is very good, and there's no need for a full .NET web server. The application can be hosted as a static site on a CDN, which allows for easier scalability. As for the cons of the client-side model, the initial request may take longer since everything has to be downloaded first. However, here, caching will help out with subsequent requests. Debugging in WebAssembly is decent, with only a few limitations, and it keeps getting better. I still put this under a con though, because it's not as robust as the server model. Now, the biggest con here is the potential for performance degradation. First of all, the entire app needs to be downloaded. I've already mentioned that part. But also some algorithms and calculations run a bit slower. Finally, the most recent approach is the hybrid approach. I'll mention it only in this lesson, but the rest of the course does not touch upon this model at all. The hybrid approach allows us to reuse existing components across mobile, desktop, and web. It allows full access to the native capabilities of the device that the app is running on. And developers can use their existing skills and experiences and resources to create these native-like apps. As for the cons, the usual native app development roadblocks come in here. You have to build separate native client apps, deploy them, and maintain them for each target platform separately. And for the end user, native client apps usually take longer to find, download, and install than accessing a web app. When you start a new project in Visual Studio, you'll need to choose your hosting model. But don't worry, most of the code you write for your application will be reusable, regardless of the model you choose. The main differences lie in the startup files and the base HTML file where everything is hosted, and we'll discuss that next. In this lesson, I'd like to show you the different hosting models that are available. We're going to start from scratch with a new Visual Studio project. Now, I'm going to show you both of these models in a brand new Visual Studio solution. So what we're going to do is actually create a blank solution and then add 2 new projects to it. Here on the Visual Studio screen, we can click on Create New Project. Now here you'll see Blazor app as one of the templates for a new project. We will use that and we'll get to that. But first, let's create a solution where we're going to have 2 projects in one solution. Up here in the search bar, search for blank and then find blank solution. Here it is. I'm going to click Next. And then let's give our solution a name. Blazor Apps. Click Create. And this will create a new Visual Studio solution. Nothing in it. In order to create new projects here, I'm going to right-click, Add, and then New Project. We're going to get this screen back that you're already familiar with. Here you can select either Blazor Server App or Blazor WebAssembly App, in other words, client-side app. Now again, I just want to mention that the code between these two, the component code that you're going to build, is going to be the same. And the Telerik UI components are also going to be the same. The only difference is the initial setup, and we'll go through that. So since this is a server project, I'm going to select Blazor Server App here. When you hit Next, you're going to give your Blazor app a name. So I'm going to give this one blazorapp.server as the name of the project and click Create. There's our project with the necessary files. And I'm going to go ahead and run this right now to see what the default template looks like. The project builds and you'll see this kind of sample application. Now this might change, of course. This is just a sample that comes with the template, but this provides a couple of different features of Blazor that's demonstrated. For example, we have navigation here where you can switch between different tabs and you'll see that reflected in the URL. You have a counter here and you have a click me button. So if I click this button, you'll see the counter increment. And in this case, because this is the server model, with every click that I perform here, there's a call to the server updates the count and returns back the differences to update this current count display. There's also fetch data here that's going to fetch this table data from the server. Let's focus in on the Blazor app server files here. You'll see that we are configuring the server-side Blazor here, as well as the ability for us to configure some services for the server to use. Let's create another project, and this is going to be the client-side project or the WebAssembly project. I'm going to right-click on the solution and click on Add, New Project. And in this case, I'm going to use Blazor WebAssembly app as the template. I'm going to call this blazorapp.wasm for WebAssembly. I could call it client, but I want to be specific that we're using WebAssembly here. And I'm going to click create here in a moment, but I want to point out one thing here. This checkbox right here might be a little confusing to some people. The ASP.NET Core hosted. What does that mean? Well, in the real world scenario, your client-side WebAssembly application will probably still need to talk to some kind of backend. So yeah, you could create a WebAssembly app and just have the app hosted in the browser as a WebAssembly app, and it's going to be a completely standalone app that does not need a backend. But most likely, your application will need some kind of backend. You could create a backend in any technology stack that you like, a Node backend or an ASP.NET Web API. This gives you the ability to create an ASP.NET Core backend that goes along with this application. We're not going to do that in this course, but that option is there for you because it is a common scenario that you will have both the backend and the front end in one solution. Let's click Create here. So now we have two projects side by side here, a server project and a client project. Now to start up the client project, you can right-click on the project and click on Set as Startup Project. And you'll see that it's bolded in here. That means that when I click Run in IIS Express now, the client-side project will start up instead of the server one. And this might look quite familiar to you, and that's because it's using the exact same components that the server project used. We have navigation between the different pages here. You will see that the URL also updates in the same manner. The counter works. But in this case, when I click me button here, this gets updated in the client, in the browser. There is no call to the backend each time I click on click me. Everything is done inside the browser. I'm going to click on F12 here to open up Developer Tools in Chrome and click on the Network tab. And then I'll click on the Reload button in Chrome and click on Empty Cache and Hard Reload. This will force the download of the entire application again. This way we can see what resources are being downloaded. So let's take a look here. Down here, you'll see a list of resources that are downloaded. And we have some style sheets, we have some HTML, we have some JSON files, and we also have a few DLLs. Now, these are .NET assemblies that are being downloaded here, and you can't see the contents of them, of course, but you can see that we do have quite a few DLLs being downloaded. These are the DLLs that are currently utilized by our application. And some of them are small, and some of them are a little bit larger. If we go into the project and go to Pages, Counter, this is the Razor component. You'll see here that we have the increment count method, and this is inside our code block in the markup. And when we click this button here, we trigger this increment count method. I'm going to put a breakpoint right there, and I want to demonstrate what happens when I click the Click Me button. So when I click Click Me, we actually are able to debug even the client-side application. Here we can step through the code and debug the client-side app, click continue, and this will come back to update the current count, and you'll see the current count is 1. We can update it and it becomes 2. So there is debugging in Visual Studio for client-side applications. Now let's quickly take a look at the differences in the code. In the server project here, we also have the pages folder and we have the counter. And you'll see that the two counter components in the server side and the client side are identical. And this is one of the benefits of building these Razor components for Blazor, is that you can use them interchangeably in your client projects and in your server projects. And when we start using the Telerik UI components in here, the story is exactly the same. We're going to be able to use them interchangeably. So what is different? Well, the initial boot up sequence is different, and some of the file structure around that is different. For example, in the server app, we have this host.cshtml file. This is the base HTML document where our application lives. And it has the .cshtml extension because this is part of ASP.NET Core. And you'll see that we have an app area here where we're hosting our app component. This is the root of our application. One more difference I'd like to point out here, this script tag right here. Notice that it says blazor.server. This blazor.server JavaScript file orchestrates the entire SignalR connection between the server and the client. Now let's take a look at the client side. And notice that in shared, we have the same Razor components that we have in the shared folder of the server project. And in the pages folder, we also have the same components. These are the pages, but we don't have that host.cshtml. So where is this page hosted in the client-side project? Well, there is the www root folder, and this is the static files that are deployed with your application. We have this index.html. So for client-side projects, we just deploy an index.html file, and that's it. Here, you'll notice that the script that we include is a little bit different. In this case, we're including the blazor.webassembly JavaScript, and this file orchestrates the connection between your Blazor application and the assemblies that are downloaded to the client. And those are the big differences between client-side and server-side. Now, since in this course we're focused on components and Telerik UI components specifically, I'm going to give you a basic introduction to components for the rest of this chapter. And if you want to jump ahead to Telerik UI components specifically, if you're already familiar with Blazor components, then you can head to the next chapter. If you worked with ASP.NET technologies before, Blazor might be a little different for you because the main focus of Blazor is building single-page applications by creating components and the composition of those components. In this lesson, we'll see component composition, and I'll use the terms pages and components, but it's important to know that these are just Razor components. Every page is a Razor component, and every component can be a page. Let's now take a look at the basics of components. Right now, we're going to continue where we left off in the last lesson. I have these two projects created, the server model and the client-side model. Now, going to the server model, I'm going to open up shared and then main layout. And here you'll see a basic component. This is a layout type of component. If you're coming from the world of ASP.NET, think of this as a master page in a way. In your server project, app.razor is actually the root component that gets rendered inside of the page. Remember the page I showed you here, the host page is host.cshtml, and this is the HTML page. And inside here, we render a component, and we specify that the type of component is app. And app here in this case refers to the class app. By default, Razor components get the same class name as the file name. In our case, counter.razor will have the class name counter with a capital C, and fetchData.razor will have the class name fetchData with a capital F and a capital D. These generate classes behind the scenes, not something you have to worry about unless you're doing code behind, and I'll show you the code behind model in a little bit. Let's create a very basic component here. I'm going to go to the shared folder, and I'm going to right click on it and click add Razor component. I'm going to give this component a name called hello.razor. Here you'll see some HTML at the top, and you'll see a code block. This is called a mixed approach to creating components. Again, these components generate the class behind the scenes. So in this case, hello is the name of the class. And you can write C# code right here in this file inside the code block. Since this is a class, whatever code is in here in this code block is going to be part of that class. So we can have properties, fields, and methods here written in C#. For example, I can create a public string called name, and I'll give it the name Alex. This field here becomes part of the class. You can see it here, hello.name in the popover here. So in our h3 tag, I can say hello, and then in order to access these fields and properties from code, from the class, I would use the @ symbol. Whenever I wanted to switch into code, I would use the @ symbol. And now it gets highlighted in yellow, which tells me that I can write C# code in these blocks. @name will automatically provide me the value for that field after the word hello right in line inside my HTML. This is a simple component here, and we can use it inside of other components because we can compose components. For example, we have our index raiser component where it says hello world, welcome to our new app. I can just remove all that, and instead I will have our component, which is hello. Now notice that if Visual Studio detects that what you've typed in here is actually a component and not just HTML, you will get special syntax highlighting. Now, in order to run this in IIS, I need to make sure that my Blazor server project is running, but I also want to run my Blazor client-side project as well. So let's right-click on the solution and click on Set Startup Projects. This way I can start up multiple projects at the same time. And here it says Startup Project. I can select, instead of single startup project, I can select multiple startup projects. And select Start from the action of both of these server and WASM projects. Let's click OK there, and I'm going to click on Start up here, which will start both of those projects up. On the right side, we have the server project, and on the left side, we have the client-side project. And you'll see that on our index page, we're rendering the hello component, which says hello Alex. Great. So that's a basic component. Now, if I wanted to use the same exact component with the same exact code in our client-side project, all I would need to do is copy that hello component, and let's go to Blazor client-side project, and I'm going to paste it in here. There's our hello raiser component in our client-side project now. Now all I need to do is go to index.raiser here and do the same thing I did before. I'm going to add the hello component in here. And you'll see that now we have the server project and the client-side project. They both share the exact same code. So components is where you'll have the bulk of your UI defined and your logic flow for the UIs. That'll be reusable. There are special types of component called pages. And the way you specify a page is by giving it a page directive like this at the very top. And then you'll give it a route. So in this case, our index page is accessible with the / route. So if I wanted this hello component to be accessed directly by a route, I can indicate @page and then /hello. And let's also do the same thing with our client-side component, page hello. This will automatically be added to the routing data. And when you run the project, that route, that /hello, will be available as part of navigation. So not only is that hello component available to be used as a child component of other routes, but you can now go to /hello and you'll see hello Alex there as well as a standalone component. Let's do it here on the server side as well. And there we go. Now you'll see the shell is still there. And that's because the shell is outside of the scope of that component and the route. The shell is provided by the main layout in both the server project and the client-side project. Those are two different types of components. They're actually the same components, but one indicates that it can also be a navigable component by specifying a page. And those types of components that specify page are typically placed in the pages folder here, just by convention. In the previous lesson, I showed you the basics of components, and we saw an example of inline code blocks where the C# code is actually part of the Razor file. This is fine for most scenarios, but if you have a more complicated component and you want a little bit more separation between your C# code and your markup, there is another method you can use to separate that out, and that's using a Code-Behind file. Here is our Hello Razor component in the shared folder of the server application. Right now, this is just a standalone file, and this hello file generates a hello class behind the scenes. I've mentioned this before, but it creates a partial class. You can add to that class with a regular C# file. So I'm going to right click on shared, add, and then class, and I'm going to add a C# class here, but I'm going to use a convention. So hello.razor.cs is the convention we're going to use. So it's the name of the file for the Razor markup .cs. I'm going to click add here. And what you'll see Visual Studio do here is actually create that file, and you can fold the code up like this under the Razor component so you can hide these extra code behind files. Now we're not done here with this class. As you can see, this is underlined because Visual Studio recognizes that we already have a partial class named hello. That's from the Razor component that we created. So this class cannot be a full class. It needs to be a partial class. So we need to specify this as a partial class. But not only that, this is a component. So we need to inherit from component base. Component base is coming from Microsoft ASP.NET Core Components. And now this is a code behind file for our Razor page. Let's say I have public method here that returns a string. Let's call it get last name. And I'm going to return my last name. Now we can just interact with that code directly in our markup by calling it like this, or we can interact with it through the code that's on the page. For example, I can say Alex plus get last name. Or I can interact with it inside the code block here. You can think of each code part having access to the other code part. So you can access methods in here. For example, let's have a public method here called getFullName. And what this will do is return name plus get last name. And you can also interact with whatever you defined in here from the code behind. So let's say we have another method called getFirstName, and this will just return name. Real quick here, I just wanted to show you one new feature that Visual Studio has that's going to save you a lot of time when creating code behind files. If you find that your code is getting too long in the Razor file, you can create a code behind file by putting your cursor between the @ and the code symbols here, and then on your keyboard pressing Control period. This will give you an option to extract block to code behind. Click that. This will automatically generate the code behind file for your Razor page. Here it is. It'll create the class, it'll import the namespaces, and it'll also put all the code you've had from the Razor page into the code behind, thus cleaning up the Razor page. Something for you to be aware of, and it's a feature that I really enjoy now. In this lesson, we're going to continue learning about Blazor components, and specifically, we're going to look at component events. Here's our hello component, and just so that we don't get everything confused, I'm going to close all the documents except for this component that's in our server project. I want to stress that this code that we're about to do and that we have done so far is going to work exactly the same way in our server project and in our client project. I'm going to add a button here, just a regular HTML button. And since we do have bootstrap styling here, which you don't need to know, but we do already have it in the project, and therefore it's going to be available for us to use, including IntelliSense that Visual Studio exposes. So I'm going to style that as a button and primary button, which is going to give it some coloring. And I'm going to give this button a text, click me. Now in the days of JavaScript, we would have to define an on-click handler here and then specify a JavaScript function. You can certainly do that with Razor components as well. However, we're here to learn about how to do this using C# code. So for any HTML element, and that's what this button is right here, you have the ability to tap into the JavaScript events, but you can intercept them using Blazor. And the way you would do that is by providing the @ symbol and then whatever event you were going to handle in JavaScript. So instead of just on click, we would say @on click. And this will tell the engine that this is a Razor event and we want to trigger C# code here. So you can even see that this @on click attribute turned purple because Visual Studio detected that this was Razor syntax. I'm going to call a function called update name. If I leave it the way it is right now, you'll see that we get an underline here, and Visual Studio says that name update name does not exist in the current context. Here we have a choice because we've created a code behind file for our component. We can either define update name as a method in the code behind, or we can do it right here in line in our code block. I'm going to do it right here in line. I'm going to create a public void function called update name. Now, you might be wondering why I said public here. Well, that's just habit, but you can make this a private method because we're dealing with the same class. So this is being called within the same class, and this can very well be just a private method. So private void update name will work just fine. I'm going to say name equals Jack, and let's run this code. So right now I'm interested in the server project. We have hello Alex Ziskind. I'm going to tap click me here, and it's going to turn into hello Jack Ziskind. Notice there was no refresh of the page. What happened when I clicked click me is a call was made to the server using SignalR. The name property was updated, and the difference was sent back to the client to be rendered again here as Jack Ziskind. So that's event handling in Blazor components. So far in this chapter, we've seen examples of how to do one-way binding for data binding and for event binding. Sometimes though, we need to do two-way binding, and we'll see a lot more examples of this in the code that we're going to write for our project. But for now, let's take a quick look at how to do this. Let's say that we had an input field here, and it's going to be of type text. This is just a plain HTML field. Now, in order to use two-way binding, we would use the @bind attribute. As you can see, that's valid Razor attribute is being recognized as such. And we're going to bind this directly to the name property. So that means that anything we enter into this input is going to be bound to the name property, and updates to this input are going to be reflected in the name property, and therefore our H3 should also be updated. Let's take a look. Here's a simple example of that. We have Alex already in the text box, and that's because we're bound to the name property, and name property was initialized to Alex. And whenever I update this text field, let's say I want to say Alexander, and I click out of the text field, it needs to lose focus in order to actually do the update. I'm going to click out of here, and you'll see that we get an instant update at the top here in that H3. Because at the point that I click off of that text box, the name property of the class gets updated. And because the name property was data bound here as well, every instance of that name binding got updated as well. But we're not quite done yet. This was a simple HTML element, but in Blazor, we tend to compose components. So let's create a new component here, and we're going to call it myInput. Let's remove the H3, and we're going to copy some elements from here. For example, this button and this input. We're going to abstract this away into the myInput component. So let's paste the HTML up here. Let's rename this property to myname and update myname just so that we have a difference here from the parent component. We're going to create a public string myname in the child component. And of course, we need this update name method as well. We're going to copy that from the parent. Myname equals, well, let's call this one Bob. And this method needs to be update myname. Okay, so far so good. And this is not any different than what you're used to. I enter some text in here, click me, and this becomes Bob. Notice we've lost that binding to our parent component's label. How do we get that binding back? And also the initial value of that input, even though it's bound to my name is not set to anything. So the text box is empty initially. Well, this is where we can use bind from the parent, and we can bind a specific property. Notice IntelliSense is helping us out here. And there's a certain convention that Blazor uses. We use the name of the property. So my name is the name of the property. And we say bind dash my name and whatever you want to pass in there. In this case, I want to pass in the value of this name property from the parent component to the child component. Now, I'm going to run this, but this is going to break, and I'll show you why, just so that you're familiar with this message. MyInput has a property matching the name myname, but it does not have a parameter attribute. Simple fix. We go to the parameter that we're trying to bind from the parent, and we just label it as a parameter by putting a parameter attribute above it. Well, that's great, but we're still getting an error. My name changed is not a parameter now. And this is because when you use this kind of binding syntax to a custom component, Blazor by convention expects that there's another property defined on the child component that's called myNameChanged. So we need to define that here, and it's of the type event callback. Now, event callback is a generic, and that takes a value. We know we're working with strings here, and we're going to call this myNameChanged with a getter and a setter. This also needs to be a parameter. And when we run this now, you'll see that we do get Alex populated into that input field from the parent to the child component. And if we click on this button, this updates. But wait a minute, now the parent is not updated. So to get two-way binding working with a child component, there's one more step you need to do. You need to call this myNameChanged callback. So over here in the update myName method, first of all, this is a void method, but we need to make it an async task type of method because we're going to await myNameChanged and we're going to invoke async it with the new value, whatever that value may be. Right now, I'm not following best practices. I'm just going to hard code Bob in there, but it'll give you an idea of what you can do here. Now, when I press click me, not only does our text field update, but also the parent gets notified there was an update to the name property and the parent's label also gets the update. Most of the components you're going to be working with that have two-way binding in the Telerik library work exactly like this. And I encourage you to look at Microsoft documentation on binding to learn more.